Okay, we're looking at a Hewlett-Packard 1220a dual channel oscilloscope. It's 15 megahertz a channel. It's been repaired, somewhat refurbished, recalibrated, and it's working beautifully, and it's a beautiful looking instrument. Hewlett-Packard made a lot of great products, competing heavily with Tektronix for the longest time. And this is one of those products that was at their lower end, but was very well put together, as I will show you an interior view and give you a little tour of the unit. Right now what we're looking at is we're looking at a 400 hertz 0.5 volt RMS signal, and you can see I have intensity here, I have focus. There's a reasonable level, and you can see the pattern looks very nice. What you don't know is that that's not one pattern, that's actually two. I got both channels superimposed over one another. I did that because I just wanted to show off the fact that it's been calibrated, and we're able to do that. Both channels are tracking each other extremely well. And we're going to take this thing through its paces in a moment, but for now, let's just give you a look at it. The unit's in remarkable shape. Put a handle on it. It didn't have a handle. It was missing it, but put it back on. And the stand is functional. Let's get a peek at the rear end here. Okay. So a very nice unit, nice shape, and quite pleased with the way it turned out. So let's take this thing through its paces, and then you decide if it's in as good a shape as I seem to think it is, huh? Okay, thank you. I wanted to take a minute and let you see the insides of this 1220. Hewlett-Packard absolutely did a marvelous job. I mean, this is first class. The layout, the type of boards, the parts, even right down to using styrofoam containers to control the temperature of certain transistors and so on that are sensitive, keep the drift down. Nice looking interior. The scope tube is shielded. Everything's in good shape. So we'll put her back together and run a few tests. Okay, well, before I do anything, I want to calibrate my probe. My probe is on the ×10 position. I'm going to the probe adjustment point, and I can see that, yeah, my probe definitely needs to be adjusted. So this particular probe has a slot in the bottom here, and I'm going to use a little screwdriver, and I'm going to provide myself the squarest looking wave on the screen. Okay, that's overshoot, undershoot, right about there. Looks pretty good to me. Okay, I do that because that's going to make my my probe at its most responsive with the scope. It has calibrated the capacitance to match the scope, and also it proves that the probe adjustment point, just right here, is working fine. Wanted you to see that. Okay. Bear with me a moment and we'll... Okay, don't want to spend a whole lot of time and belabor the point too much, but what we're looking at right now is a 0.5 volt peak. It'd be 1 volt peak to peak, 400 hertz signal, and it's from a calibrator. This is from a Fluke 5220a AC calibrator. It's used for meters and scopes and such. And we're feeding in, since this is a peak signal on the scope, that's different than feeding in an RMS signal. The Fluke device is RMS, so I have to take the 0.5 volt peak that I want and I have to multiply it by 0.707, and I wind up with 0.35355, and that's what I've got coming in, and it comes up exactly 0.5 volts peak, which is good. That means my calibration is good on this this particular 200 millivolt per division. If I go to 500, we go up 1 division and down 1 division, so that's perfect too. If I was to go to 1, you'd only get a half a division up and down. I can't go to the 100 without going off of the screen, because you only have 8 divisions to go up, and that wouldn't be enough. We'd have to go 1,000. So, or excuse me, we'd have to go 5 divisions up, 5 divisions down, so a total of 10. And if I go to channel B, and let's check our... There we go. And once again, we rise 0.5 volts and then we go down 0.5 volts. So exactly like the other channel. This is at 200. Here be 500 millivolts per division. Here's 1 volt per division, and the appropriate response. I've checked the frequency response. It's dead on. If I go 1 megahertz to 15 megahertz, you can read the frequency right off of the screen. If you see one trace going over the 10 cycles, or I mean the 10 divisions, then you know, I could give you an example of that. We'll do that in a minute. So we're calibrated good in the vertical on both channels, and let's go ahead and take a look at the frequency. Okay, I'm hoping that we'll be able to see everything clearly here. Trying to fix this so you can see both the gradical and the traces. Right now, I'm feeding in a 1 megahertz signal from this Hewlett-Packard 3320b, which is a digital device, produces extremely accurate signals for me. And okay, we're set right. 200 millivolts per division, doesn't really much matter, but we're going to go ahead and we're going to notice that we start on a gradical, we come up, we go down, we finish on a gradical, and we do that on the line all the way across. We are hitting the gradical every step of the way, which is exactly what we want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get 10 peaks and 10 divisions. That's 1 cycle per division. We're on a 1 microsecond per division scale, and we're feeding in a 1 megahertz signal, so that all figures. We get 1 cycle in 1 division because it's 1 microsecond in length. If I was to go to 10 times that speed, then we should only see one trace, and we should be able to adjust that trace so that we start on the gradical, and in 10 divisions we finish on the gradical 10 divisions away. And that's exactly what we've got. This is at 1 megahertz. And if I was to take this up to 10, there's 10 megahertz, and we will adjust the trigger. There we go. Trigger's working very well. And I should be able to adjust this so that we see that it falls on every gradical just like we did a moment ago. Let's see. Alright, we're on the gradical here. We hit it here, we hit it here, 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 all the way across. So we're 1 division in length. That's perfect. And this is 10 megacycles. Okay, we're going to go ahead and give this this unit a bandwidth test. And right now I've got a 1 megahertz signal adjusted to give me 6 divisions on the gradical. This might help. And what I'm going to do is I'm going to take the frequency up to 15 megahertz, and so long as we're within 4.2 divisions on that gradical, we've got our bandwidth. That's a statement right out of the manual. Here's 12, 13, 14, 15 megahertz right here. And let's make it so we can see it. And what we see right now is that we've got 2.4 in the positive direction, 2.4 in the negative. So we've got about 4.8 divisions, and we needed 4.2 or better. So we've actually gone better than our 15 megahertz rated bandwidth. If I was to go to 4.2, let's just see where we go. I'd see it's right in there. It's about 19 megahertz, so that's on channel A. Let's go ahead and take her down. Alright, back to our 1 meg. Let's change channels to B. Alright, there's our 1 meg. Make sure we're, there we go, positioned properly. So we have 1 meg there. And let's take her up to 15. There's 11, 12, 13, 14, 15. And what we see is 1, 2, 2.2, 2.4, 4.8 peak to peak. So it's just like channel A. Let's go ahead and take her up, see how high we go before we hit the limit. Oops. I'm gonna say maybe 20. Yeah, 19 to 20. So we have our bandwidth on both channels. It exceeds the 15 megahertz that it's supposed to have. We've almost reached 20 on both channels. We're in good shape. The bandwidth went up to just about 1920 megahertz. So it's 5 megahertz better than is actually rated. That's not unusual for Hewlett-Packard. They are usually very conservative with their ratings, and this one proves it out. It's a beautiful device. About the only thing negative I can tell you about it is that we did have a crack on this one dial. I used some super glue on it, so I would just say, you know, be gentle with the dials. It should last just fine. I'm not having a problem with it, but you know, if you were to real quickly ratchet the thing and wrench it or whatever, you might crack it. But outside of that, there's no flaws on this cabinet. It's in very good looking shape. Handle on the side that I put on it again, it was missing that. The stand's in working order. We have a nice intensity. Focus works really good with it. Both channels work very well. I think you're going to like the scope. Probe adjustment's working good. So there you go. I'll try and find out when this unit was made, but I'm kind of guessing that we are looking at the early 70s, maybe even the late 60s, but I'm going to guess around 70. So that being said, we're talking over 40 years old, and it's in remarkable shape, working great. Thanks for listening.